Hi Huskies, welcome back. We're on day 6, the last one of matrices. So we're going to solve this using inverses for this one. So we're going to set it up like we did on day 5 as a quick reminder and then go from there. All right, so let's make sure we put them in order. So 2, -10, -12, and -42. My second one doesn't have an x, so I'm going to make 0 for the placeholder. 5, -17, and 50. And then my third one, I have 11, 6. I don't have a z, so that's a 0, and then -27. So I'm going to find the inverse of the first one times the constant, and let's find the answer to this one by plugging it in. So what do we have? We have a 3 by 3, and so second matrix, plug it in. So we have a 3 by 3 ready to go. Let's plug in the numbers. Lots of tapping. Apologize for that. All right, so I have my matrices for my first one, second mode or second quit. Then I'm going to go back into the matrix, edit my second one. My 3 by 1 is ready to go. And what are my constants? -42, 50, and -27. So those are my numbers. Second quit again. Go back into matrix. Type in a to the -1. Find the inverse times matrix B. And I have these answers. They are in decimal form. So now I'm going to change them to a fraction. Whoa. So these are pretty wild. So maybe I want to just keep them as a decimal. All right, so I found the inverse of A times B, and these are my answers that what I got for these. So for X, Y, and Z. All right, the fractions aren't really that much prettier. So -7,047 over 1367. 1367 is the denominator for all three. So either way, either in decimal form or in fraction form. If the fractions are nice, I like to keep them in fraction form when I can. Okay? So this is the inverse way. So when I'm solving a system of equations, one way I can do it is by using inverses. Find the inverse of the coefficients and times it by the constants. Today is what we did in Unit 1. We had 1 day of it, okay? And instead of doing all that work, I'm going to put it all into one matrix, and that's called RF. That is a code in the calculator. The main one that we're having issues with is when you guys have to quit, right? So we have to make we make our beautiful matrix, okay? I have to delete all this stuff. Sorry, apologize. So second matrix, so I have to make it, and then I have to go second, quit, and get out, okay? Once I get out, it makes things a lot easier. So I make the matrix, I have to make it. I quit, I get out of there. I go to the math, so I have to go to the middle category, which is math, okay? Edit is the third column, math is that one, and I'm going to pick RF. RF in your calculator. So if I go to second matrix, go to the math column, RF should be number, in mine it's B, some of yours it's number 9. So just scroll down in math until you find it. You put RF and then what your matrix is and enter. And what you'll get is you'll get what's called reduced row echelon form. So what that means is it's coded in order to tell you. So the first row will be 1, 0, and then a number. You know that that number that's attached to that 1 goes with the answer. So this 1 means that the X value is A. For the second row, that means that this Y value is B. So everything else in the row should be zeros other than what is like the place value. So this is the X value, which means A. Because this one is in the second spot, that means the Y value is B. In the third column, the third spot means that that answer would be your Z, okay? And et cetera, et cetera. So again, you'll have a 1, 0, 0. What is the answer for A? Or what's the answer for X? What is the answer for B? What is the answer for, so this would be X, Y, Z. And then if I kept going, so if I had a 3 by 3, or what if I had a 4 by 4? A 4 by 4 would just mean that you would have an extra 0, and you would have 4 columns. So 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And then again, what would these numbers coincide with? Again, what is the place value of where the 1 is? So that would tell you what your answers are. Okay, so instead of doing inverses, which is what we did on day 5, you can use RF to solve systems of equations. Okay, what are the different forms? So like I've been talking about, this is the general form. Okay, and what does this mean? That there's one solution, okay, for your answers. You have one solution. Now for this one, there's something going on here. So I have 0, 0, 0, 1. Okay, so what on earth does that mean? Okay, well, is there a placeholder here? It doesn't look like there's a 1 here. Okay, so this would mean, well, I have an X, I have a Y, but I don't have a Z. So this means that there's no solution. And think of it this way. Can 0 equal 1? No, that's a no solution. So that means that there's not a Z value, or there's a missing value for this one. Okay, so if there's not a placeholder of a 1, if it doesn't make this beautiful pattern, something's amiss. Okay, compared to if you have 0, 0, 0, 0, well, does 0 equal 0? Yes. So this would be infinitely many solutions. Okay, so that means that more than one solution works. Okay, so those are the 3 different types of results you could get. All right, so let's get after it. Let's try this out. So instead of making 2 matrices, we're going to make 1. So I have 2, -7, and -10, 3, 8, and 22. Okay, so I'm going to make it into 1 matrice. Okay, 1 matrice, and I'm going to use that RF. So I'm going to use RF and this matrice, and it's going to tell me the answer. Your calculator is going to know that this last column are your constants. All right, so I no longer have 2 matrices. I have 1 matrice with all the information. So in my first 2 columns are my coefficients, and then my constants in my last one. Okay, so 2 by 3, ready to go. Now I'm going to go back in. So second matrix, go over to math, and go down to RF. Okay, RF, then second matrix, I'm going to type in A. I want to find RF. So what you notice is that pattern of the 1, 0, 2, and then 0, 1, 2. What does that mean? So in the first placeholder, 1, 0, 2. So let's write that down. So 1, 0, 2 is what I got as my answer, and then 0, 1, 2. So it's like I'm getting a clue. Okay, so this means that X equals 2 and Y equals 2. This is my placeholder for my X, and this is my placeholder for my Y. Okay, so that's how the calculator codes it out and lets you know what those values are for X and Y. All right, so let's try number 2. Setting it up first. So I have 3, -1, 2, and 7. 6, -2, 1, and 8. 2, -1, 3, and 8. Put it into the calculator. And what type of, this is a 3 by 4. Okay, so it goes row by columns. So edit, so a 3 by 4, and let's type these in. Once it's typed in, I kind of check every row. So 3, 6, I check every column. 3, 6, 2, -1, -2, -1, 2, 1, 3, and 7, 8, 8. Just kind of helps to make sure that I have everything good to go. Second, quit. Okay, then I'm going to go down to second matrix again, go to math, go all the way down to RF. Okay. Just the fancy way, row echelon form, very fancy. Enter and enter. So let's see. I have X equals 1, Y equals 0, and Z equals 2. So be careful. So if this says 1 equals 0, that means if you have this pattern of this diagonal of 1s, you do have one solution for each one. I don't want you to be stressed and be like, wait, there's a 1 and a 0. That means that Y equals 0. Okay, so X equals 1, Y equals 0, and what was that Z again? Z equals 2. And there we go for our answers. Okay, for number 3, this is a little bit trickier. So I have y equals ax squared plus bx plus c. So what I need to do is I need to find out what my a, b, and c, what are my coefficients for each of these, and then solve them. So all I know is what my x and my y value is, and then I can solve it. So negative 2 squared is 4a minus 2b plus c, and that equals 7. Okay? So that's what I have for the first one. Okay, now let's try for the next one. So I have negative 2 is my y value, and my 1 is my x value for each one. And I'm going to figure out what those coefficients are. So b is times 1 plus c, and I can solve that. So I have negative 2 equals, so 1 squared is 1, so a, and then 1 times b is still b plus c. So that is my second point. And now I have to figure out my third one. All right, so I have plugged in. So I have 3 as my y value. And then I'm going to plug in 2 for my x values. So 3 equals, so 2 squared is 4a. Plus 2b plus c. Okay, so it's kind of funky. I don't know what my a, b, and c are. I don't know what my coefficients are, but I did know what my x's and y's are. All right, so this question is pretty hefty. So what I'm going to do now is I'm going to change it to a matrix, okay? All right, so I'm going to make this a1, and I'm going to change it around so then I have 4a minus 2b plus c equals 7. So I'm just switching it around so I'm kind of getting it ready for a matrix, okay? Now what does this mean if I put it into the matrix? Well, I'm going to plug in 4, negative 2. Instead of c, well, the coefficient is 1 and 7. So that's how I'm going to change that one. Let's try the next one. So I have a plus b plus c equals negative 2. So how do I plug that in? 1, 1, 1, negative 2. And then the last one, I have 4a plus 2b plus c equals 3. Let's plug it in. 4, 2, 1, and 3. So that's how I'm going to write it. And then again, think of there's like an imaginary line there. So, okay, all right, I had my coefficients, and I have my constants, and now I'm going to figure out how I'm going to write this. So let's put it into a matrix. All right, so I have the matrix. So 4, 1, 4, negative 2, 1, 2, 1, 1, 1. All right, 7, negative 2, and 3. So second quit, second math, second matrix, math, and I'm going to go all the way to ref. Then I'm going to go back in, click A, and here I go. So my x is 2. My x is 2. Oh, but for this one, I'm trying to, instead of finding out what x, y, and z are, because I know what x, y, and z are, what am I trying to find? I'm trying to find my a, b, and my c. So that's a little bit different. So I'm trying to find a, b, and c for this, not my x and y. I know what that is. So my a is 2, my b is negative 1, and my c is negative 3. So y equals 2x squared minus x minus 3. Ta-da! So instead of trying to find x, y, and z, I had to find a, b, and c to write my quadratic because we're amazing. All right, so I think we have a few more to go. So let's write this one out. So now we have more of these magics. So now we have w's. So 3, negative 1, 8, and 1. We've got 1, 2, negative 1, and 4. 1, 5, negative 5, 1, and negative 5. 2, 4, negative 2, and 1. Sorry, I'm a little tedious on this and saying all of them out loud. It helps me. 7, 0, 6, and 1. So let's see. How many rows do I have? I have 4. And how many columns? 1, 2, 3, 4, 5. So a 4 by 5. Again, ref. And then let's plug this in and see what we get for these answers. All right, guys. So we're going to plug in this matrice in. And then we're going to go second quit, second matrix, go over to math, RF, go back into matrix, click A, and enter, and here we go. And here are our answers for W, X, Y, and Z. Let's see if I can make them into fraction and make them a little bit nicer. And there we go. So we have 2755. Looking at the last column, 19 over 11. Maybe your teacher likes decimals more. I like having them in fraction form, 83 over 55. Sorry, I have to keep going back and forth. And the last one is 63 over 55. So what does that mean? My X, my Y, oh wait, so sorry. My W, my X, my Y, and my Z. So again, looking at those columns, okay, and seeing the order of your 4 variables. All right, what will the reduced matrix look like if there's no solution? So we already talked about that. That means that you're going to have all zeros equaling 1 would be a no solution. Infinite solutions would mean the last row would be all zeros. Make up a 3 by 3 solution that has the solution of 1, 2, and 3. So my X has to be 1. My Y has to be 2. And my Z could be 3. And then what could that equal? So 1 times 2. So that would mean my last column was 1, 2, 3. And then this could be my 3 by 3 system that has a solution. So my 3 by 3 system. So again, X equaling 1, Y equaling 2, and Z equaling 3. And you could ask your teacher if you wanted to make a more complicated problem, but that would be your result of your answer. All right, thank you so much for joining me, and let your teacher know if you have any questions. Have a great day, Huskies.